Okay, this is the P1 paper from June 2022. This is question 5, and if we look at it, we can see it's a quadratic graph, and it's going to lead on to some completing the square work as well. Let's read it and get started. So it says the curve C is a quadratic. It looks like a quadratic, like a negative quadratic to me. It's got a maximum turning point at minus 212, and it cuts the negative axis, x-axis, at minus 5. Can we find what that quadratic is going to be? Right, well, before I do that, what I really need to do is just a quick bit of reminder work on completing the square, and when we have a completed square, what that actually tells me in terms of being able to sketch. So completing the square is when we have a quadratic that we've reduced to something similar to that. Okay, P lots of x plus q all squared plus r. P, q and r are all constants. They can be positive or negative. But if I do have a situation like that, the whole point about having a completed square is it means it's easy to work out maximum and minimum values. For example, when I'm looking at this, the maximum is going to occur, so maximum will occur when x plus q all squared is equal to naught. Okay, that's going to give me my maximum value, because the smallest value anything squared can be is naught. So if I then get y equals naught plus r, straight away r will be the y value of the maximum point that we have. And when is that going to occur? Well, that's going to occur when x plus q squared equals naught. In other words, when x plus q equals naught, so when x equals minus q. So if I have the maximum point, that'll be the x value of it, and that'll be the y value, the x coordinate and the y coordinate from that you should already know. So I've just quickly gone through that, but now what that means is that when I'm looking at my question that we've got here, we can simply say, I wouldn't write all that down, I'd say, whoops, maximum point is going to be equal to minus q r here, and we know from the question that the maximum point is minus 212. So if the maximum point is minus 212, then straight away I've got q is 2 and I've got r is 12 in my work. So that means that my function now is y equals p x plus 2 squared plus 12. So the only value I haven't got now, the only constant I've now got is p, but we also know it goes through the point minus 5 naught. So for the point minus 5 naught, what that then means is when x is equal to minus 5, y is equal to naught. So naught is equal to p minus 5 plus 2 squared plus 12, and we can now just tidy this up. So naught is equal to minus 5 plus 2 is minus 3, but minus 3 squared is going to be 9, so 9p plus 12. So in other words, p will work out to be, let's do it slowly, 9p works out to be minus 12, p works out to be minus 12 over 9, or better than that, minus 4 over 3. So now my function, I've got it, is minus 4 over 3, x plus 2 all squared, plus 12. So the original curve that we've got there works out to be equal to that. Okay, let's look at part B. Part B says we've now got this line L here with the equation y equals 4/5 x. Yeah, that seems to make sense. Given that L1 is that's L1. Given that L1 is perpendicular to L2, okay, so we've got L1 and L2 here. Yeah, there's a right angle there. They're perpendicular to each other. I know that means something about the gradients, probably what I'm going to be using. Given that L2 is perpendicular to L1 and passes through the point minus 5 naught, can we find the equation of the line? Yes, we absolutely can. That's a really straightforward thing to do. and they're going to want it in the form y equals mx plus c, which if I forget, I'll always go back and check at the end of doing this question. So let's just make it clear what we're doing then. So they've told me, which one? L1 is 4/5 x? Yeah, they've told me that L1 is y equals 4/5 x, which means gradient equals 4/5. Therefore, gradient of L2 is minus 1 over 4/5, which I'm just writing that down to show what I'm doing, but actually I don't think about it like that straight away. I think about it just turn the fraction upside down and make it negative. So I know the gradient of L2, I've got a point on L2, so I can find the equation. So equation of the line, I'm always going to use y minus y1 equals mx minus x1. What do I need to have? I need to have a gradient, well I've got that, minus 5 over 4, and I need to have a point that is on the line, and in this case it's the point minus 5, 0. So we've got minus 5, 0 there. So in this equation, I've got the three things that I need. The y and x will just stay obviously as variables. So let's just chuck everything into that. So I've got y minus 0 equals minus 5 over 4 x minus minus 5, so be careful with that, x plus 5 there. And at this stage, you should have seen this a lot. Don't mess around with this. Right, multiply everything by 4. So I get 4y equals minus 5 x plus 5. Now multiply out the bracket, minus 5x minus 25. And if I didn't think now, I'd write that down as 4y plus 5x plus 25 equals 0, you know, our sort of AS level way of writing down a straight line. But they did tell me in the question, and I did remember, no, they want it in the form y equals mx plus c. So I've got to do each one individually by 4 here. Minus 25 over 4. And then going back, that's what they said that they wanted up here. So they said, give your answer for L2 in the form y equals mx plus c. So we've done that. And then part C is an inequalities bit on the end of this question. It says, define the region shown shaded using inequalities. Okay, hopefully straightforward. So this inequality is underneath the quadratic. So it's going to be less than or equal to the quadratic, but it's above L1 and it's also above L2. When we're thinking about it, it's above this line, but below that line. That's where we get the shaded region there. So just need to be careful when I say all that then. So for part C, so we've got that it was underneath the quadratic, so less than or equal to minus 4 over 3 x plus 2 squared plus 12. But it was above both of the other two, so above the 4/5 x and above the minus 5x over 4 minus 25 over 4. Just check all the boundaries are solid lines, so it should be less than or equal to, greater than or equal to, rather than less than and greater than. So, yep, that's all of that question. Hopefully that makes sense.